Good afternoon. Our topic is fire detector alarm. My team members are Amruta, Sahana, Arshia, and me, Nurain. These are the contents: project overview, sensor data acquisition and processing, data structuring and cleaning, communication and alert mechanism, result interpretation, performance assessment, system reflection, and improvement conclusion. My, my part is project overview. Core components: Arduino Uno, flame sensor, buzzer, LED. Purpose: detect fire early and alert surrounding people. Work using infrared light, IR light detection from a flame. System gives instant alert when flame is detected. The flame sensor detects infrared radiation emitted by fire. We use Arduino Uno to read this data and trigger alert immediately when fire is present. This project uses an Arduino Uno, a flame sensor, a buzzer, and an LED to detect fire early. The flame sensor detects IR light from a and sends a signal to the Arduino. When a flame is detected, the system instantly turn on the buzzer and LED to alert people. The goal is to provide quick fire detection using simple and fast IR sensing. Next slide is about the flame sensor. The flame sensor detects IR infrared wavelength from 760 nanometer to 1100 nanometer. It gives a digital output where low means flame detected and high means no flame. It reacts very fast, very quickly, and uses an LM393 comparator for accurate detection. The sensor is highly sensitivity and can detect flame from a short to long distance depending on the size of the flame. It contains an IR receiver and comparator circuitry that quickly identify fire signals. Next slide is sensor data acquisition and processing. Arduino Uno continuously reads digital output from a flame sensor. Flame detects logic. If it is output is low, it it identifies fire present. It considers the area safe because the sensor gives clean digital data. No filtering or delay is needed. The Arduino Uno the Arduino Uno processes the signal immediately and activates the buzzer and LED to warn instantly. This eliminates the need for data cleaning and gives very reliable result quickly. Next part will be continued by Arshia.
Thank you, Nuran. My part is data structuring and cleaning. Our system works in a real time, meaning it does not store data in a memory or send it to the cloud. Because we use a digital flame sensor, the output is already clean and reliable. Digital output has several advantages. No noise in the signal, no fluctuation, no false values unless there is a strong environment interface. Data is already in a clean binary format 0 or 1. Since the data is clean from the sensor itself, we don't need to perform extra structuring or cleaning. This helps the system respond instantly whenever a flame is detected. Next slide is communication and alerts mechanism. Our project does not rely on IoT protocols like Wi-Fi, MQTT, or Bluetooth. Instead, we use a local alert system that works even without internet connectivity. When a flame is detected, but the buzzer turns on, LED turns on. This ensures highly reliable immediate response, no risk of network failures during emergencies. Using only local alerts makes the system more stable and suitable for fire safety environment. Next slide is data flow. In the complete workflow of our system is simple and efficient. The flame sensor detects infrared radiation from fire. The sensor sends a digital signal to the Arduino. The Arduino checks whether a flame is present. If flame is detected, buzzer and LED active. If no flame, system stays in a monitoring mode. The Arduino continuously processes data in a real time without any interruption, making the system reliable for constant fire monitoring. Thank you. Next part will be continued by Amruta.
Thank you, Ashia. And my part is system requirement and the hardware requirement. The components are Arduino Uno. Main controller processes the sensor input and controls the buzzer and the LED. Then the flame sensor detects the infrared radiation from the flames and sends the signal to the Arduino. Then the buzzer produces the audible alarm when the fire is detected. Then the LED provides a visual indication when the flame is detected. Register and the jumper wires ensure the safety connect flow and a proper circuit connection. Breadboard used for assembling and organizing the circuit components. Power supply. It connects the power supply to the Arduino and the components. Connecting cables used for the connecting Arduino to the computer for a programming and power. Next part is software requirements. The software requirements are Arduino IDE platform to write, compile, and upload the code. Here we use a C language used for a program sensor logic and control output. Computer used for developing and uploading Arduino components. USB driver enable to communication between a computer and Arduino Uno board. These are the requirements of our project. Arduino Uno flame sensor, breadboard, LEDs, and jumper wire, register, USB cable. The fire detection alarm system was tested using different frame sources under the controlled condition. During each trial, the system continuously monitored the flame sensor output. When a flame was brought close to the sensor, the infrared radiation level increased, causing the sensor to give a low signal to the Arduino. This low signal was interrupted as the fire detected. Immediately after the detection, the buzzer produced a loud alert sound and the LED turned on, indicating an emergency condition. When the flame was removed, um, the sensor output turned to the high and the buzzer and LED turned off, showing no fire. The response time was exactly quick within the millisecond. Then the system indicates detect the flame accurately in all positive test cases. No false alarm occurred in the absence of fire. The detection range worked efficiently within the uh, distance. Thus, the result confirmed that the system performs accurately and consistently in a real time. The result prove the reliability of the flame sensor and ensure that the system can trigger a timely warning to the avoid fire accident. Next part is performance assessment. To evaluate the system performance, key parameters such as accuracy, response time, stability, and the sensitivity were analyzed. The high accuracy correctly identify the flame in all test conditions without misinterrupting normal light. Fast response time, instant alert activation help in early flame prevention and safety. Low cost and low power system, the component used to the affordable and consume the minimal power, making the system practically for homes and small industries. Then the limitations, detect the fire only, works efficiently only when the flame is within the short distance of the sensor. Then the range limited by the sensor sensitivity. Strong sunlight or reflective environment can affect the sensor accuracy. Then the flame, then the strong sunlight or reflective surface may cause interference. The fire detection alarm performed well under the test condition and proved to be a efficiently safe and a quick alert system. The system demonstrates a strong potential for a fire safety enhancement with minor improvements in a future version. Thank you. Next part is continued by Sahana.
Thank you, Amrita. My part is system reflection and improvements. Here, what worked well means instant response and clear visual and sound alerts and simple circuit and programming. It gives good accuracy during testing. What challenges we faced means sensor sensitive to strong light, false triggers in bright environments, and limited detection range. There is no remote monitoring, and we can enhance using adding GSM to send mobile alerts and adding smoke sensors or temperature sensor for multi-hazard detection and increase detection range using frame sensors arrays and add enclosure to reduce false triggers from sunlight and adding real-time data logging to SD card or cloud. Next we will see the conclusion. Successfully detects fire using frame sensor and provides immediate audible and visual alerts, and it is simple, reliable and effective for basic fire safety, and it is also suitable for homes, labs, workshops and industries like small industries, and it is easily scalable into fully fledged IoT monitoring system. Overall, our system works accurately and quickly. It is simple but effective in early fire detection and can be expanded in future. Thank you.
So now we gonna see our project. Here the flame sensor module typically has 3 pins. One is VCC. It connects to 5-volt power supply, and another one is ground. It is connected to ground connection, and another one is digital output used to detect the presence of flame. Next, connect the VCC pin of flame sensor to the 5-volt Arduino and ground to ground, and connect the pin of the sensor to digital pin 8 on the Arduino, and attach the LED to digital pin number 13 with 220 ohm resistor in series. Connect the buzzer to digital pin 9. These are the connections, and the components are Arduino Uno, flame sensor, LED resistor which has 220 ohm, and buzzer with jumper wire and USB cable. Now we see what the code and the output. So this is the code of our project, and now we have to run this project code. First it shows there is no flames detected. Flame. Huh? So we will get buzzer and LED, and the output as flame detected.